Yeah. Yeah, good evening all. Before I start, can anyone please confirm whether my voice is clear, right?
Yes, sir.
Yes.
Yes. So in the previous class, right, evolution of Apache Spark was introduced in the year 2009, open source in the year 2010, donated to Apache software in the year 2012. Defining Spark, distributed execution, cluster computing framework, parallel process style, in-memory computing, used for large-scale data processing. In-memory computation, right? The data gets loaded into RAM and data gets processed within the RAM. Data gets loaded into RAM, data gets processed. That's why very high speed we are going to see, right? Data divided into partitions. The partitions are distributed across multiple RAMs of multiple worker nodes. So, we have seen this why PySpark. Okay. PySpark is designed for fast computation, used for running distributed SQL, creating data pipelines, ingesting data into databases, running ML algorithms, data streams, and working with graphs. Spark has got multi-language support, can run on multiple languages, right? Yes. Scala, Python, Java, and R language. Spark by default written in Scala. Scala is the native language of Spark. Need for PySpark. So both it's a Python API to use Spark. So both Python and Spark combinedly was introduced by Apache Software Foundation. Python and Scala. So Python is dynamic type, it is static typed. Has powerful libraries for machine learning, graph, and streaming, right? But as compared to Python, Scala has got less. There's a huge community, but this community of Scala is less. There's many applications, but only for Scala is only for Spark environment. Python, the only thing is Python is slower as compared to Scala. Scala is faster, right? Scala is faster than Python because in Python, interpretation line by line execution. PySpark features in-memory computation, lazy evolution means on-demand executing the data flow until then it won't execute. Persistence means reusing the results of already executed transformation. Powerful fault tolerance. If any machine goes down, Spark has the capability of regenerating the lost partitions. Immutability, no changes or modifications to the original data remain same. Partitioning, Spark data objects are divided into multiple partitions and distributed and processed parallelly. So used in commercial sector, in healthcare, in entertainment industry, in e-commerce and tourism industry, right? Executing is yesterday I was just briefing you the differences between these different technologies, right? Okay. Spark features and advantages. In-memory computation, distributed execution, flexible parallel process, flexible high speed transformations can be reused, good for iterative algorithms, multi-language supports advanced analytics. Yesterday I was discussing about Spark data objects RTD, right? Spark data objects RTD. RTD is again subdivided into partitions. RTD is again subdivided into partitions. These partitions are distributed across multiple RAMs of multiple worker nodes and are processed parallelly. RTD programming style, yesterday I was discussing that it's a data flow. Data flow means sequence collection of pipes. A pipe means any data operation like loading data, transforming data, filtering, grouping, merging, right? In Spark, data flow executed sequentially. That is RTD by RTD, one after the another in DAG style with in-memory computing feature and persistence feature. In-memory computing feature and persistence feature, right? So all two RTDs can never execute parallel because the output of one RTD is taken as input to the next RTD. But if the RTD, where you can see the parallel processing means if a RTD has got 10 partitions, if the RTD has got 10 partitions, these 10 partitions can execute parallelly. The RTD1 output is taken as input to the RTD2. RTD2 equal to RTD1 dot transformation. How is RTD2 got generated? RTD2 got generated from RTD1 if you are applying any transformation. The resultant, whenever you apply any transformation or filtering, the resultant is an RTD. Okay. On RTD, two operations we can perform. Transformations, actions. We have got many inbuilt transformations and inbuilt actions. So transformations, again, three types. Each element transformation, filter transformation, right. Each element transformation, filter transformation, right. Now, each element transformation means whatever logic you are applying will be applied on each and every record, right? Yes. Okay. Transfer, okay. Adding 5,000 to the salaries of each employee, right? Yes. Filter transformation, filtering based on some condition, aggregated transformations, aggregations and groupings and aggregations, right? Yes. So what are the action? Action means whenever action is performed, right, then only entire data flow will be executed from X root RTD. The following are some actions. So the entire data flow won't execute. I said it's lazy evaluated. Whenever you perform any action, then only the entire flow executes. Collector. It collects the partitions present in different worker nodes, right, into the client machine. Count counts the number of elements in an RTD. Counts the number of elements in a RTD. Take retrieves the first n number of elements of an RTD. Retrieves the first n number of elements. Take off n here. We say take off n. Take off n means takes the n number of elements of an RTD, right? Save as text file. If you want to save the results, you want to storing the results of a computer.td into HDFS. RTD dot save as text file. RTD dot save as text file as Spark. On RTD, if you apply any transformation, the resultant also is an RTD. On RTD, if you apply any transformation, the result is also an RTD, right? On RTD, if you apply any action, the result, an action if you apply, the result is not an RTD, it is a local object. Understand here? On a RTD, if transformation applied, the result you get is also an RTD, Spark object. On a RTD, if you apply any action, then local object, Python object you are going to see. Now check this. One example. Example, right? Yes. How this RTD1 is created? RTD1, how it is, RTD1, how it is created? Spark context dot text file. Spark context dot text file. File1 dot txt. The path we need to specify from a file using Spark context. So here I'm writing, right? Whenever we load a file, using Spark context, then a RTD is created. Whenever we load a file using Spark context, then a RTD is created. On this RTD1, just now I discussed some transformation. Some transformations only I have discussed, but
Children transformation.
what is
Map.
map is one.
Flat map.
Flat map, filter,
Filter.
group by key, reduce by key. Group by key and reduce by key, right? Yes. Okay. So if you use on RTD1, if you perform any transformation, is map is a transformation. RTD1 dot map. The resultant, whatever we get, RTD2. So on the RTD1, if you apply any transformation, you got RTD2. The result, whatever you get, is nothing but RTD2. So here I'm writing a comment for your understanding. Comment means in the which has in Python comment, right? Right. If we apply transformation on RTD1, RTD2 is created. Next, on this RTD2, RTD2 dot filter, RTD2 dot filter. Some filtering condition you provide. Same thing. If you apply any transformations or filtering on RTD2, then RTD3 is created. RTD3 is created. So in this RTD2 dot filter, the resultant RTD3 is created. RTD3 equal to RTD2 dot filter. Similarly, on this RTD3, RTD3 dot group by key. RTD3 dot group by key. If you are performing some group by operations, RTD4 is created. RTD3 RTD4 is created. Again, on this RTD4, in this way, any kind of transformation can be a filter or grouping or mapping or some reduce by key is there. One more transfer reduce by key. Later I discuss what are they, what they perform, but perform any built-in functionalities, then RTD5 is created. RTD5. Then RTD4, then RTD5 is created. You know, what is your observation on an RTD? If you perform any kind of transformation, it can be a map transformation, it can be a filter transformation, it can be a group by or reduce by key, anything, right? So these are aggregated transformation, this is filter transformation, this is each element transformation. Each element filter and aggregated transformation. Finally, on this RTD5 dot
Need
collect
to perform action.
action. Some collectors is an action. Store it in RES. What is RES? Try to answer. On a RTD, if action is performed,
Python object will be created.
then we get Python object. Previously, on Spark object we used to get, but whenever you say any action is performed, collect or count or take or whatever, right? Okay, then action is performed. Now the entire data flow gets executed. Now the entire data flow gets executed. from the root RTD. From the root RTD. The entire data flow gets executed from the root RTD. Entire data flow gets executed. Now try to answer what a query. Where all these 5 RTDs, where all these 5 RTDs are stored. Where all these 5 RTDs are stored.
RAM. Name nodes.
All the 5 RTDs will be in the RAM.
No, empty.
Yes. I mean, it will be, the recent one will be on the RAM. The first, previous one will be nullified. I mean, deleted. Only output of the each individual RDD ones will be available.
So here the RTDs are just declared. Here RTDs are just declared. If we perform action one by one RTDs gets loaded. They gets loaded into RAM, right? And will be processed.
Sequential.
Gets loaded into RAM and will be when we perform, then one by one gets loaded and will be processed. And
When the process is complete.
whenever the next RTD is ready, and computed, then the previous RTD, will be removed from the RAM.
From the RAM.
Previous RTD will be removed from the RAM. This process continues. This process continues until the action is executed. This process continues until the action is completed. Okay. To perform act, then one by one RTDs get loaded into RAM. Look, whenever the next RTD is computed, the previous RTD will be removed from the RAM. This until the action is executed. Once the output is collected, once the output is collected, then the last RTD also gets removed. Last RTD also gets removed. No, no RTD in the RAM. No RTD in the RAM. We can trigger the next flow. Here, all RTDs, here all RTDs won't be loaded simultaneously. Here all RTDs won't be loaded simultaneously. Here all RTDs won't be loaded simultaneously. So here all RTDs won't be loaded simultaneously, right? Yes. So here all RTDs won't be loaded simultaneously. They'll be loaded one after the other. They will be loaded one after the other. As I said, they'll be executed sequentially. They'll be loaded one after the other. Transformations, right? Are executed. Transformations are executed at Spark cluster side. Transformations are executed at Spark cluster side. Spark cluster side, right? After performing action, the result is stored. The result is stored in the client machine. Client machine is the machine from where you are submitting the Spark job. Right. Okay. So, yeah. Understand this flows now. Check this. Everyone. Check these flows. R1, R2, R3, R4, R5, R6, R7, R8, R9. Check this flow, right, everyone? Right. How many flows? Flow 1. Three flows are there. Flow 1, flow 2, flow 3. Three flows are there. In flow 1, R1,
R1,
R2,
R2,
R3,
R3, R4,
R7.
R7.
Flow 2,
R1,
R1, R2,
R2,
R3,
R3,
R5,
R5,
R8.
R8.
Flow 3,
R1,
1,
R2,
R2,
R3,
R3,
R6,
R7,
R9.
R9. Three flows. First, executing flow 1. Executing flow 1, flow 2, flow 3. Observe, executing flow 1. To execute flow 1, what I need to do? Generally, it won't execute automatically. To execute, right, what I need to do? To execute any data
Need
flow.
to perform.
Yes. For example, R7 dot action. Action means collect or count or collect, take, many actions are there, right? R7 dot action. Whenever you perform R7 dot action, the execution starts from its root RTD. From R1 to R2
R2,
to R3,
R3,
R4,
R4, R,
R7. See, R1 output is taken as input by R2. When R2 is ready and computed,
R1 gets removed.
when R2 is ready and computed, R1 gets removed from the RAM. When R3 is ready and computed, R2 gets removed from the RAM. When R4 is ready and computed, R3 gets removed from the RAM, right? When R7 is ready, R4 gets removed from the RAM. Once the output is collected, R7 also removed, right? Now, no RTD in the RAM. No RTD in the RAM. Executing flow 2. Executing flow 2. What I should from on which one I need to perform action?
R8 dot action.
The last RTD in that flow, right? If I give action, R8 dot action. How the flow goes?
Start
R1,
from root RTD. R1,
R2,
R2, R3,
R3, R5,
R5, R8.
R8. Once R1 is loaded, all its partitions and computed, the output is taken by R2. When R2 is loaded, computed, R1 and its partitions gets removed. When R3, because all these RTDs can't be accommodated. When R3 is loaded, computed, R2
R2 gets
removed from the RAM. When R5 loaded and computed, it removes all these
R3
R5
gets
partitions.
removed.
When R8 is ready and computed, it removes this R5.
R5
Now, once this output of this R8 collect, then R8 also removed. No RTD in the RAM.
already.
Executing flow 3. Executing flow 3. R1, R2,
R9, not
R3, R6,
R4.
R9. When R1 and its partitions loaded computed, the output is collected. Output of this R1 taken by input by R2. When R2 loaded computed, R1 gets removed from the RAM. When R3 partitions loaded and computed, R2 gets removed from the RAM. Whenever the next RTD is ready and computed, the previous RTD gets removed. This RTD loads and computed, this gets removed from the RAM. Finally, once this output is collected, R9 also removed from the RAM. What is the drawback you observe in this flows?
Every time from root RDD, it is keep on executing.
Common RTDs are executing multiple times.
So here,
So we can
first,
persist R3.
in all the three flows, these first three steps are common. In all the three flows, first three steps are common, right? Here, first three steps are same. Three steps are same. Every time we are re-executing the three steps. Every time we are re-executing. Every time we are re-executing. So to avoid this, every time we are re-executing the flows. So to avoid this, persistor, the RTD, whose output is commonly used by multiple flows. So avoid this. So every time we are re-executing the flow, so to avoid this, persist the RTD whose output is commonly used by multiple flows. Persist the RTD whose output is commonly used by multiple flows. Which RTD's output is mostly used by multiple flows?
R3.
R3. Persist it. How to persist? R3 dot persist, we say. We say R3 dot persist, fine. It gets persisted. So if it gets persisted, what is the advantage you are going to get?
Every time it's only initial time only, it just starts from root RDD. Rest it gonna start from RDD3.
Subsequent flows will use the persistent RTD.
R1, R2, R3, R4, R5, R6, R7, R8, R9. This is our flow. This one is persisted. What advantage you are going to get from this persistence? For example, executing flow 1. Executing flow 1 means what I should say, R7 dot
Action.
R7 dot action. Whenever you say R7 dot action, it executes from its root R1 to R2, R3, R4, R7. So here the first flow executes completely. R1 gets loaded, computed, and its output taken by the next. When the second RTD is ready and computed, the first one gets removed from the RAM. When R3 is ready, R2 gets removed. When R4 is ready, this gets removed, right? When R7 is ready, this gets removed finally. But here, sorry, when R4 is ready, R3 will it be removed? When R4 is ready and
No, it's not removed. It is
so
stored on
R3
the
is
RAM.
persisted, right? R3 is persisted means make it available in the RAM, even though the next RTD is ready or computed. Even though the next RTD is ready and computed, it won't get removed, right? Yes. When R7 ready, R4 removed. When the output is collected, R7 also removed. Means what is present in the RAM? R3 in the RAM. Whenever you persist any RTD, the meaning of persistence means it will be available in the RAM only, even though the next RTD is ready and computed. Now executing the flow 2. Executing the flow 2. Understand here, whenever you say R8 dot action, how it is going to be computed means first R8 you are saying, I want R8 output. I don't know about the other RTDs. I want the R8 output. R8 output means
Start executing from R3.
see R8 first you will check, okay, for R8 to compute, I require its input. R8 input is R5. Is R5 available in the RAM? No, right?
No.
No.
Next, it will check whether R5 I want to get R5 output. R5 input is
R3 is available.
R3. R3 in the RAM.
Is available.
So the flow is no need to execute from the starting. It will start from R3 available.
R3.
Its output will be given to R5. Its output given to R8. That's it. When R5 is ready, still R3 available. When R8 is ready and computed, still R5. When R8 is ready and R5 gets removed, when this output is collected, when the
R3
output
is
is
in
collected, R8 also removed. So R3 in the RAM in this case also, right? If you have got any queries, you can ask. I'll show you multiple flows. R3 in the RAM here also. And now try to execute this flow 3. Executing flow 3.
R9 dot action.
R9 dot action. R9 output I want. I doesn't want all the remaining output. Just I want R9.
R9 checks input R6.
R9 input. First it should from where R9 has to get the input. R9 input is
R6.
R6. R6 input
R6 input is
R3.
R3 is available in the RAM.
So no need to re-execute this first flow, right?
Yes.
Directly the flow will be the flow, right?
R3.
R3.
R6. R9.
R6. R9. This will be computed already computed. When R6 is ready, R3 gets removed from the RAM.
Hmm. Is it removed or is it still available on the RAM?
Sorry, R3 will be there in the RAM, right? So
Yeah.
because it is persisted, R6,
Yeah.
when R9 is ready, R6 gets removed.
R6 gets removed. Output collected, R9 is removed.
When the R9 output is collected, R9 gets removed from the RAM.
So
Now again R3 in the RAM, right? Here also R3 in the RAM. Means what is your observation? Whenever you persist any RTD, which RTDs you will persist? Which RTD will persist means the RTD whose output is
Common
commonly
RAM.
used by multiple flows. That RTD you will persist. Okay, here R3 is persisted.
so until we remove this R3 explicitly, it will be in RAM only.
Yes,
Is it?
exactly, right? So R3 will be available in the RAM. So if all the three execution flows got executed, right? Still R3 remains in the RAM.
Okay.
If R3 not required, so here if R3 not required, forcefully unpersisted. Forcefully unpersisted that R3. R3 dot, say R3 dot unpersist. Forcefully remove it. 3 ways to unpersist. Three ways to unpersist. Okay, before that, right? I'll come back, right? You can, I got some queries. First one. What is lazy evolution? What is lazy evolution in Spark? Generally, which RTD will be persisted? What do you mean by persistence? What is persistence in Spark? Which RTD will be persisted? Different ways to persist in RTD. Different ways to unpersist in RTD. Different ways to unpersist in RTD. What are the situations? What are the situations, right? Yes. Where RTD will be removed, where RTD will be removed from the RAM. What are the situations where RTD will be removed from the RAM? What is lazy evolution, right?
Output is executed.
On demand, executing the
Execution flow.
data flow by providing action. Until then, it won't get on demand executing the data flow by providing action. What is persistence in the Spark? Making the RTD available in the RAM. Even though
the flow is executed.
even though the next RTD is ready and computed. Understand this? Making the RTD available in the RAM itself, right? Even though the next RTD is ready and computed. Which RTD will be persisted generally?
Common.
Which RTD will be persisted generally means the RTD whose output is commonly used multiple flows. That RTD will be persisted. Different ways to persist an RTD. Different ways to persist an RTD. Two ways. RTD dot persist. RTD dot persist, RTD dot cache. Different ways to persist in RTD means two ways. RTD dot persist, RTD dot cache. What is the difference between persist and cache? I'll discuss. Means they have got some persistence options where you want to persist in memory or in disk or in memory and disk, both options, right? So this persist will take all that options, but cache only takes only memory only option. Takes only one option. It will take all the four options are available. Let I discuss the difference between these two. Different ways to unpersist in RTD. Different ways. Three ways. Three ways to unpersist. Three ways to unpersist. Forcefully unpersisting. Forcefully unpersisting in RTD. By saying RTD dot unpersist. Once your entire flow is completed, now forcefully unpersisting it. When the session is closed, it gets unpersisted, or when server shutdowns. When server shutdowns. These are three ways to unpersist. What are the situations where RTD will be removed from the RAM?
And session is closed when server is down.
First is whenever next RTD is ready. The current RTD, whenever the next RTD is ready, the previous RTD gets removed, right? This one way. Second way is persisting. Unpersisting means it won't remove. Means here in this case, okay, forcefully unpersisting means okay. But here, when next RTD is ready, the previous RTD gets removed. Second way is when action is completed. When action is completed, when action is execution is completed. When action or execution is completed, the last RTD gets removed. These are the two ways, right? These situations where RTD will be removed. Whenever next RTD is ready, previous RTD gets removed. When action or execution is completed, the last RTD gets removed. Right? Okay, fine. Understood this entire RTD computation, everyone, right? Everyone understood this? Any query in this? No. Now, what try to say the steps in RTD computation. Steps in RTD computation. Step 1,
Transformation. Reading RDD.
initially all RTDs
Reading
are declared. All RTDs are
declared.
declared. We load one by one RTD. We load one by one when action performed. When action performed. Then one by one
RDD
one
is
by
loaded.
one
RDD is
RTD
loaded.
gets loaded
And perform.
and computed. One by one RTD loaded and computed. When action is performed, the one by one RTD loaded and computed. Here the flow execution. Here the flow execution starts from root RTD or
RDD.
Always will it start from the root RTD
No, or persisted RDD.
or available RTD in the RAM? Or available RTD in RAM. It is persisted RTD. The flow execution starts from the root RTD or available RTD in the RAM. Step 2. During flow execution, where this execution is happening in the disk level or RAM level? During flow execution. During flow execution, the RTD partitions or each RTD partition, you can say each RTD partitions will be loaded into RAMs, into multiple RAMs, and computed in a RAM.
Yeah.
It's loaded into RAM and computed in the RAM. One second. Execution happening parallelly or sequentially?
Sequentially.
Here, each RTD loaded one after the other, one after the other. And computed sequentially. And computed sequentially. Step 3. Once the RTD execution is complete, once the RTD execution is completed, once RTD execution is completed, it waits. Next RTD. If the next RTD is ready, if the next RTD is ready,
Current RDD gets
then the what about the previous RTD to it?
previous RDD gets
Then the previous RTD will be
removed.
removed. Removed from the RAM. This process will continue. Until the action execution is completed. Step 4. Whenever action is performed, whenever action is performed, whenever action is performed, all RTDs are stored and computed. All RTDs are stored and computed at Spark side, at Spark side. Spark side means the Spark cluster machines. And the final result of the final output is final output is collected and stored on in the client machine. In the client machine. Client machine means client machine means machine from where the job is submitted. Step 5. Next, during this execution, right? During the flow execution, the RTD, output which is commonly used by multiple flows will be persisted. The RTD output which is commonly used by multiple flows will be persisted, right? Yes. Finally, the RTD stored, right, in RAM can be unpersisted. It is no longer required. Okay. Finally, the RTD which is no longer required. This is the steps required, right? Understood this entire completion of RTDs, right? Yes.
Hi, sir. I have one small question on persistence. Like whenever you persist one that RDD, so that means it will occupy the memory of that size. Like if you have 10,000 rows and whatever the size of the 10,000 rows data, when you persist, so that memory will be occupied.
What do you mean by RTD? Data object. Whatever is the size, right? Whatever the data object.
Yeah. Whatever data object size is.
Data object is divided into multiple partitions. Whatever the number of rows, whatever the size, right, is divided
Yeah.
into multiple partitions. All the partitions are distributed across multiple RAMs of multiple systems.
Okay.
And then processed parallelly. It may be whatever that partition size, right? So distributed and processed.
So that partitions will be persisted on the cluster, Spark cluster.
Yes. They won't get removed. They are not going to get removed, right? If the RTD is persisted. All the partitions. But here you may just fault tolerance in Spark is important because your data is distributed across multiple systems here. In many systems you got. But suddenly if any system goes as they are machines, right? If any system goes down, right? Any system goes down. Then multiple ways Spark has got the capability of regenerating the lost partitions. That we have what I'll discuss multiple cases, right? What happens, for example, there are multiple ways. I'll just say, right, in the next session, I'll give you the total idea about this fault tolerant model. See, R1 is there, RTD1 is there, R2 is there, R3 is there. From where R3 has to get the input from R2. The output of this should be collected by R3. While collecting R3, when collecting the output from R2, suddenly if this any one machine from this R3 is down, if any one machine means if the current RTD is down, if the current RTD machine is down, that is one case. Second, for example, here R1, R2, R3 is there. From R2 you are collecting, who is collecting? R3. From R2 output is collecting. Well, okay, during this collection process, suddenly if R2 machine is down, R3 didn't get that input. R3 didn't get the input. For example, R1, R2, for all this set, I'll be discussing the solutions. R3, R4, R5 is there. In that, R3 is the persisted RTD. R3 is the persisted RTD. Is okay, fine. While R4 output is collecting by R5, while R4 output is collected by R5, suddenly while during this collection process, R4 is down. This machine or anything is down. Then what happens? Very simple. Let already R3 available, take this output, recompute R4 and just get it right. Understand here. Already R3 available in the RAM. Take its output and recompute R4. R4 output take by R5. Can I persist multiple RTDs? Can I persist multiple RTDs?
Yes.
This R3 output is used by multiple flows. This R5 output is used by multiple flows. I can persist multiple RTDs. I can also persist multiple RTDs. So here you may ask, what is the main advantage? One of the main feature of Spark is persistence. So that whatever I discuss, these 4 to 5 cases I'll be discussing in brief, right? Okay, next. For example, main advantage of this RTD, persistence. In this way, 50 are there. R1, R2, R3, R4 up to R50. R50 output used by R70. This used by R80, R90. These 3 flows are using this. But what is that? What are the rules in the persistence you need to understand? At least one flow should be executed. First flow should execute completely. There's no other choice. During this only it will persist. Which RTD I need to persist here? R50.
R50.
Because its output used by multiple flows. First flow you execute, but second flows, third flows, if other flows, right? No need to re-execute from the starting. In the case of Hadoop, it is re-executing. It always re-executes from the starting. Directly from R50 you can go, the flow will be from R50 to R80, right? 50 steps minimized, right? 50 steps got reduced. No need to execute the first 50 steps. Already R50 output is available. That output you take and compute this flow, second flow. $50 steps are ignored in that second flow. And third flow also, right? No need to execute from the starting. No need to re-execute from the starting. Directly R50 output and this flow is enough. That is what the advantage of persistence. It is persist. If it is not persisted, right? If no RTD is persisted, and second flow, third flow also, again you need to start from the beginning to this end. From the start to end, from start to end, right? Yes.
Vijay, what happens when if R50 is down?
If R50 is
Down means the machine is down.
if suddenly if any R50 machine or this RTD machine is down, right? Then
Yeah.
Spark will automatically recompute from the beginning to this R50 and automatically it will persist it. It will recompute without performing any action, right? Automatically it executes from that previous available RTD or from the root RTD, it automatically recomputes and automatically it repersists by itself. That is what the Spark feature you got, right? If any RTD persistent machine is down, right? So immediately it recomputes from the beginning or from the available RTD. If any RTD available in the RAM, assume that R25 is available. It computes from that. If not available, it computes from that and again repersists. So if R50 is persisted, right? The other flows directly, they can take their output and they can, but if it no need to, means many 50 steps are reduced, 50 steps are reduced here. Spark has powerful, the main features is persistence is one feature. In-memory computation is one more, two major features, persistence, in-memory. These two features, right, in the case of Hadoop, you cannot, they cannot reuse the already executed transformation. In-memory, three things as compared with Hadoop and Spark, right? In Hadoop, what you are not able to see in-memory computation. Second thing is persistence. Third one is in Spark, we have got flexible parallel process. You can control the parallel processing in the case of Spark. In Hadoop, we cannot control the parallel processing because it always depends on the blocks. How many blocks, those many tasks. 10 blocks, 10 tasks, 20 blocks, 20 tasks, right? But 10, you got a 10 blocks, 10 tasks, but I have got 40 systems. 40 systems, right? Yes. In the case of partitions, Sudhir Sahu, right? Sudhir Sahu, you are just playing some audio, right? Okay, please be in mute. Fine. Understood, right? This total majorly in-memory computation.
What is exactly the architecture of Sparks? What is how the in backend process is going on?
Okay. Spark, right? Spark, right? Yes.
Yes, sir.
Spark core and Spark libraries.
See here, you'll have Spark core programming, Spark core, RTDs, Spark SQL, ML, streaming. So Spark core, Spark SQL, Spark ML, Spark streaming. So it is providing this libraries, right? Spark core, data frames. For this, we have got RTDs. For this, we have got data frames. For this streaming, we have got D streams. distributed streams, DS streams. So data object for this is DS streams, for this data frames, for this it is RTD. So in this architectural part, as you asked, right, there's a concept of driver and executors. Driver and executors. If I talk about this, whenever you launch a Spark application, right?
Mm.
Spark driver is created. So this is a little early to discuss, but once you have got the knowledge, I'll be discussing it in brief. So here, partition 1 is there. So here, partition 2, partition 3. Your data objects are divided into partitions, right? Your data objects are divided into partitions. So we have got this driver. Whenever you launch this Spark application, driver process is created. Then this partition should be executed with some logic. Who provides the logic? This driver is going to provide this logic to each and every partition. Who is going to provide the logic? Logic, business logic, right? Who provides? Driver provides the with what logic they have to be executed partitions. Execution of these partitions with the provided logic. Understand? Execution of these partitions with the provided logic is carried out by another program called executor. For executor 1 for this, executor for this one more executor for this. Understand here? Whenever you launch a Spark application, one driver only, but multiple executors. Multiple executors. So got how many partitions? Those many executors. So in Spark, number of tasks. Executing a partition is nothing but a task. Executing a partition is nothing but number of tasks equal to number of partitions equal to number of executors. Many questions they ask, right? Later I discuss about this. There is a concept like a stages in Spark. We have got stages, tasks, drivers, executors. Number of tasks means number of partitions. Nothing but number of it. How many executors required if they have got 10 partitions? 10. How many tasks? How many executors required if you have got 10 tasks? 10 executors. So whenever you launch Spark application, this driver and executors. Driver is the master process. These executors are the slave process. Means the slaves are need to execute the tasks. These executors are going to process the partitions with the provided logic taken care by this executor program, right? So this is the internal architecture of Spark. Means whenever you launch it, these partitions, these drivers and executors, right? So these partitions, these are stored in slave 1, slave 2, slave 3, 3 systems, 3 slaves, 3 worker nodes. That too within the RAMs they are getting stored, right? Right. So later I discuss in brief whenever how to submit Spark job. While submitting Spark job, what are the various process created, which is the master process, which is the slave process, and how this partitions execution is happening, the different stages, and we have got a narrow transformation and wide transformations, right? What is narrow and wide? So those things I'll discuss, right? So fine. Just a small thing, right? Different ways of creating RTDs. So next, different ways. Control A. Okay. I'll just whatever we have discussed, right? Steps in RTD computations, these queries, whatever we discussed yesterday, today, right? This entire notes I'll be forwarding it to you. Just now I'll keep in your Zoom chart. I'll just paste it in the Zoom chart. You can just have a look in the next session, right? I'll be discussing about fault tolerance model, different ways of creating RTDs, different persistence options in the Spark. Only for this first 2 or 3 sessions, right? You'll be having theory. Thereafter, there won't be anything, no theoretical, everything practical, right? We'll be discussing about one by one inbuilt transformations, actions, and next like Spark data frames, right? Yes. So we'll continue in the next week with this fault tolerance, different cases in fault tolerance, different ways of creation of RTDs, different persistence options in the Spark. If, for example, if the RAM is not available, if the memory is not available to persist a particular RTD, there is a concept of even persisting within the disk instead of failing, if instead of getting the job getting failed, right? Can also persist within the disk level, right? Memory and disk means you will be giving the option memory and disk. If memory available, then in the memory you persist. Otherwise, in the disk you persist. That options are there. Memory disk. That is what all options like persist option will be taken. Persist method will take all these options, but a cache method, it will only persist within the RAM level, right? Fine. So, and one more, right? If the people who are just joining for that only by PySpark course, right? So try to get enrolled by that for the next week, right? Next week session. So next week, everyone, right? You will get a new link to your mail IDs. The people who have already got the package, right? A big data package, Hadoop and PySpark, you will be getting the link to your mail IDs. And those people who didn't enroll, try to enroll to get that link to your mail IDs. A new link next week, right? Not this link, a new link. So at 5 o'clock, we'll start the session. Right. We'll go more on this. Next, I'll also go with the next Sunday. Mostly, I'll go with Saturday. I'll discuss this. Sunday, we'll go with the practical implementation of this, right? Yes. Yeah. Any other queries? Anyone? Right. So, yes. So I'll stop for now. We'll continue on next Saturday at 5 o'clock. So just check your links. Next Saturday, I'll just create a WhatsApp group for this PySpark. For this, a new PySpark group will be created. You will be getting the videos. Check as of now, you can see in the chart, right? If you see in the chart, yesterday video or previous videos are available, right? Means yesterday video and the last week video is available in this chart. You can just copy that link. And by tomorrow morning, you will get a mail in that you will get a video link up to today's session, whatever is discussed, the videos, YouTube links will be given. But from the next week onwards, when you people, everybody have got enrolled, right? You'll be getting that videos to your Google Drive. People who have already got enrolled, right? Tomorrow itself, you can see your Google Drive. In that Google Drive shared with me option, you can see in the Google Drive, whatever email, with whatever email you are joining this meeting, check that email. From tomorrow itself, you can see the videos of this PySpark. Yes, 1 second, hold on. That notes, I'll keep it now itself in the Zoom chart. And just to go through the notes, right? 1 second. Once again, the notes I'll rearrange with some diagrams, right? I'll be forwarding you next. But meanwhile, you can just whatever we are discussed till 1 second. 1 second. Can you see in the chart, right? PySpark notes, just for whatever we discussed till now, you can see that notes. So this entire, whatever we start from this starting, what is Spark definition, why PySpark, comparison with the Scala, PySpark features, real life use cases, differently compared with different Spark and Pig, Spark and Flink, PySpark features advantages, RTD computations, how it is divided on our 2 operations on RTD, different actions, and different, what are the different lazy evolution, persistence, steps in RTD computation, right? You can check with these notes. Okay, we'll meet next Saturday, right? Yes. Fine.
Sir, can't we download this note?
Yeah, you can download from the Zoom chart right now. In the
I'm-
Zoom chart, I kept that notes. You can download it.
I'm trying it, but I'm not seeing any option to download.
Everyone try to respond. Are you not able to download it?
Yes, Sagar, I'm able to download.
You're
There's
able
an
to
icon on the top corner.
There'll be an icon. If you just move your mouse on that, right? There'll be an icon on that top right corner of that download option. Just if you move the mouse on that, right? There'll be a down arrow. Down arrow will be there, right? Download arrow. Yes. Okay. Otherwise, tomorrow again, along with this mail, they'll provide a mail to you, right? Along with the mail also, these notes you'll be seeing, right? Right?
Sir, please send that document to the mail only.
Yeah, mail also you'll be getting by tomorrow, right? Along with that to your email, the video link and the mail. These notes here with both you will be getting, right? Yes.
Okay.
Thank you, sir.
That is 2 days notes, right? Yesterday and 2 days.
Yes, yes, yes.
Yes.
What about the previous weeks, last week?
Everything from the starting. Everything from the starting you will can see, right? From
Okay.
the start, from the starting itself. So what is PySpark? Why PySpark? That is evolution of Apache Spark, defining Spark, everything from the starting. Once again, I will rearrange with some diagrams and I'll forward it, right? You will see that. It will be in the zip format. You can just extract it and you can check with that, right? It's fine. Okay.